All right, good morning and welcome to Master Talker online class. Today we'll be talking about permutation and combination. Please, if today is your first day of watching our video, please consider subscribing. Okay, now, but before we talk about combination and permutation, let's talk about factorial function or just factorial. Factorial. Okay, now factorial, just know that 0 factorial is 1. Okay, that's the only one that is odd. Just know that 0 factorial is 1. Then 1 factorial means 1 times 1, which is what? 1. Okay, 2 factorial means 2 times 1, which is what? 2. 3 factorial means 3 times 2 times 1, which is what? 6. 4 factorial means 4 times 3 times 2 times 1, which is what? What is 4 times 3? 12, 24. Okay, so 10 factorial means what? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now another thing you need to note is that what? 10 factorial means 10 times 9. If you want to stop at 9, you don't want to continue, just put factorial, because that 9 factorial still means 9 times 8 times 7 times 6 times 5 down. Okay, so which means 10 factorial can still be the same as what? 10 times 9 times 8 times 7. If I want to stop here, I will just put what? Factorial. Okay, now it's the same thing as saying that 10 factorial means 10 times 10 minus 1. Do you know that 10 minus 9 will give you 1? And 10 minus 1 will give you what? 9. I don't want to stop there. Times 10 minus 2. I don't want to stop there. Times 10 minus 3. Anywhere you want to stop, it is your choice. You have what? Just put what? Factorial. So that means that n factorial is the same as saying n bracket n minus 1, n minus 2. If I want to stop here, I'll just put factorial. But if I don't want to stop here, I'll continue. N minus 3, n minus 4, n minus 5, blah blah blah. Okay, till you get to anywhere you want to get to. So let us solve some question on factorial. Let's solve some question. Now there's a question. The first question here said 6 factorial all over 4 factorial 2 factorial. Now this thing means 6 times 5 times 4. I don't want to continue. Let me just put factorial here because I know that I have 4 factorial down that they can cancel. Then times 2 times 1. Now 4 factorial will now cancel 4 factorial. 2 divide itself 1. Divide here 3. So I'm left with 3 times 5 here, 15. You see? Very, very simple. Number 2. Number 2 said that I have 10 factorial all over 8 factorial. Very simple. Just say what? 10 times 9 times 8 factorial all over 8 factorial. 8 factorial will cancel 8 factorial. So I'm left with 10 times 9, 90. As simple as that. Okay. Now another question, number 3. Number 3 said n factorial all over n minus 3 factorial. Now what do you do? This is what? N factorial means n bracket n minus 1, n minus 2, n minus 3. I'm stopping here. Why? Because I equally have n minus 3 factorial down. And don't forget that anywhere you want to stop, you must put factorial. Then n minus 3 factorial has cancelled n minus 3 factorial. So my answer finally becomes n into n minus 1 into n minus 2. Okay, so that is that. So now let's move into permutation and combination. Let's move into permutation and combination. Okay, the terminology permutation and combination are a bit confusing to students, like identical twins. So before we go into the topic properly, we shall define both terms, given their various formula, and take simple example involving both concepts. Okay, now let's talk about combination and permutation. Yes, like it said in this book, that is confusing. Permutation and what? Combination. Okay, so now listen. A permutation n, a permutation n. Okay, a permutation of n distinct. A permutation of n distinct objects, okay, is the word arrangement. Very, very important. please know that permutation is simply means arrangement. If I put it here, arrangement. Whilst combination is selection. Okay, permutation is arrangement, while combination is selection. So arrangement of R out of, okay, is, they say a permutation of n distinct objects taking R at a time. Okay, sorry, they said a permutation of an object, a permutation of an object n, what am I right? A permutation, sorry about that, a permutation of n distinct objects. A permutation of n distinct objects taking R at a time, is an arrangement. Is an arrangement of R out of the n objects. Arrangement of R out of the n objects with attention given to order of arrangement. With attention given to order of arrangement. Okay, now the formula said that the permutation of n permutation R means what? N factorial all over n minus R factorial. This formula is very, very important. But what I want you to note in this definition is that what? That permutation is simply what? Arrangement. And you must take note of what? The order of arrangement. Very, very important. What do we mean by order of arrangement? That AB is not the same thing as BA. So you must take note of the arrangement. But in selection, once you have selected AB, it's the same thing as that you selected BA. They are the same thing. So in combination, we don't take note of the arrangement. Okay? Once you have selected it, you have selected it. But in permutation, we take note of the arrangement. Okay? Get up from there. So sorry about that. That's my dog. I have, okay, the second combination said a combination of n different objects taken R at a time is a selection of R out of n objects with no attention. Have you seen it? With no attention given to the order of arrangement. Okay, there is no attention given to the order of arrangement. Now the formula is that n combination R means n factorial all over is the same formula, n minus R factorial. But the only problem here is that you start with n factorial all over R factorial first before you now put n minus R factorial. So that's the difference between combination and permutation. In permutation, there is no R factorial under it, but in combination there is R factorial under it. Okay, so the formula is very, very simple. Okay, now another thing is that we write this thing. Another way we write this thing is by writing like this, n combination R. So you can see something like this or something like this, they are the same thing. N combination R can be written like this, n combination R. So the relationship between permutation and combination is simply this. So which means n combination R is simply, if this one is n, this one is n permutation R, so it means 1 over R factorial then n permutation R. Okay, so that is the relationship between what? Combination and permutation. Okay, that's the relationship between combination and permutation. Okay, so now let's take a question. Let's take a question. Okay, they said consider example. Consider the alphabet A, B, and C from which two letters okay, from which two letters at a time are to be chosen. Okay, now look at what we do now. But if it is permutation, let us do this by permutation and combination. Permutation, combination. Now in permutation is the order of arrangement. Okay, now we want to arrange these three alphabets in two ways. So it's going to be what? 3 permutation what? 2, which is what? 3 factorial all over what? 3 minus 2 factorial. So which is what? 3 factorial all over this minus this is 1 factorial. So which is what? 3 times 2 times 1 all over 1 times 1. So I'm having what? 6 ways. So this alphabet can be arranged in what? In 6 ways. Okay, we can arrange it in 6 ways, forming only two alphabets together. Only two alphabet. Watch it now. We are forming only two alphabet. If I have A, B, B, A, A, C, C, A, B, C, and what? C, B. You see, you can only form them by what? You can form two in 6 ways. But in combination is what you are selecting. We want to just select only two alphabets out of these 3. So if you are selecting, it's going to be what? 3, and you are selecting what? 2. Okay, which is what? 3 factorial all over 2 factorial first before you now say 3 minus 2 factorial. So this thing means what? 3 factorial all over 2 factorial 1 factorial. So this thing is them as saying what? 3 times 2 factorial all over what? 2 factorial times 1 times 1. So what? This take care of this because 1 factorial means 1 times 1. So I'm having what? 3 over 1, which is what? 3. So in selecting 2 objects here, we are going to select, we have 3 different ways of selecting it. Okay, we have 3 different ways of selecting. Let's check it. A and B, what again? A and C, then B and what? C. Okay, if you say you are selecting C and B, it's the same thing you selected. So the order of arrangement, you take note of the order of arrangement here. But here we don't take note of the order of arrangement. Okay, very, very important to note. Very, very important to note. Okay. So another example said 4 candidates. Example. Okay, they say 4 candidates P, Q, R, and S, okay, applied for scholarship in Chevron and Shell comma, each of the scholarship must go to a different candidates. Okay, list the possible ways. List the possible ways it can be awarded. List the possible ways it can be awarded. Okay. Okay, now they say that we have 4 people that apply for scholarship, and they say that each of the scholarship must go to one person. So the 2 scholarship cannot go to one person. So we can say that, watch now, if we choose 2 people like this, if we choose P and Q, okay, we can say that P got chevron and Q got shell. Are you getting me? We can equally say that the same P and Q again, we can now write it as what? Q and P. And we say that what? Q got what? The first one, chevron, and P got what? Shell. So which means this is arrangement. This is arrangement because the order is very, very important. We take note of the order. So this is arrangement. So since it's arrangement, it is what? Permutation. Permutation is arrangement, while combination is what? Selection. So we have what? 1, 2, 3, 4. We are arranging 4 out of 2. So what do we have now? 4 factorial all over 4 minus 2 factorial, which is what? 4 factorial all over 2 factorial, which is what? 4 times 3 times 2 factorial all over 2 factorial. This take care of this. I'm having what? 12. So we have 12 different ways of giving this scholarship to these people. Okay, so that is that. Let's take one more question, then we now move into the main thing. Let's take one more question just to differentiate the two. We just want to differentiate the two, then we now take the topic one after the other. Okay, we now take the topic one after the other. So we now have what am I saying? They say out of the 5 science club members of a school, comma, A, B, C, and D. Okay, A, B, C, D, E. A, B, C, D, and E. Okay? You see, just 3 are to be chosen to represent the school, in an exhibition. In how many ways can this be done? Okay, now if you look at this now, they have 5 science club, okay, and they say that you need to choose 3. So it is selection. We need to select 3 clubs. Okay, I cannot say that maybe I'm selecting A, B, C club and still select B, A, C club. No, now it's the same thing you selected. So this is selection. So since it's selection, we are going to use what? Combination, because combination is selection. So they are 5, but I'm selecting 3. So it's going to be what? 5 factorial all over 3 factorial first before I will now say 5 minus 3 factorial. That is combination for you, which is what? 5 times 4 times 3 times 2 factorial all over. Okay, let me stop at 3 factorial. 3 factorial all over 3 factorial is here. Then I'm having this minus this is what? 2 factorial. So 3 factorial take care of 3 factorial. 2 times 1 2. So I'm having 20 divided by 2, which is what? 10 different ways. Okay, so 10 different selection or 10 different ways of selecting it. Okay, as simple as that. So now let's go into the major business, which is permutation and combination. Let's take them one after the other. permutation. Now, okay, already we know the formula for permutation, then we know the definition. Please, anytime you write permutation, please write arrangement for me so that you not forget. Arrangement. Arrangement. So permutation is simply arrangement. Okay. So now, do you know the formula now? That what n permutation r is what? Up factorial all over just up minus down factorial. That's all. Okay. So if I have what am I saying? 8 permutation 2. It means what? 8 factorial all over what? 8 minus 2 factorial, which is what? 8 factorial all over 6 factorial, which is what? 8 times 7 times what? 6 factorial all over 6 factorial. So because I told that anywhere you want to stop, just put factorial. So 8 times 7 is I think 50 something, right? 56, I guess. Okay, so the next one, so now let's take some questions on permutation. Let's take some questions on permutation. But before that, what is n permutation n when they are the same thing? Let's check what happens if they are the same thing. N permutation n, it means what? N factorial all over what? N minus n factorial. Are you with me? So what do we have? We're having what? N factorial all over 0 factorial. And 0 factorial is 1. So I'm left with what? N factorial over 1, which is what? N factorial. So that is that. So, okay, now let's take some beautiful calculations on that. The first question said, remember that it is what? Arrangement, though, don't forget. So the first question said, how many ways are there? How many ways are there of arranging 3 different jobs? 3 different jobs between 5 men, where any man can do only one job. Solution. Okay, so they've already mentioned the word arrangement for you. For the fact that they mentioned arrangement for you, you just know that it is what? Permutation. Look at the word arranging. So they are talking about what? Permutation. So there are 5 men, but we are arranging what? 3 different jobs for them. So what do we have now? 5 factorial all over what? 5 minus what? 5 minus what? 3 factorial. So what am I having? 5 factorial all over 2 factorial, which is what? 5 times 4 times 3 times 2 factorial all over what? 2 factorial. 2 factorial take care of 2 factorial. I'm left with 20 times the, which is 60 ways. Okay? 60 ways. As simple as that. So the next question. The next question said, how many ways in how many? In how many ways can 8 people be seated in a bench if only 3 seats okay, if only 3 seats are available, sorry, if only 3 seats are what? Available. Okay, solution. Now we just want to get we want to arrange what? 8 people. We're arranging 8 people arrangement, because people sitting in a seat is simply you are arranging them. Or you stay here, the other one stay here, so that it will contain. We have 3 benches, we have 3 seats. Okay, they want to sit in a bench, and that bench can contain only 3 people. So in how many ways can you arrange them so that they can be so I'm having 8 people being arranged by what? 3 seats. So what do we have? 8 factorial all over what? 8 minus 3 factorial. So what do we have? 8 times 7 times let me just write 8 factorial all over this minus this is giving me 5 factorial, which is what? 8 times 7 times 6 times 5 factorial all over 5 factorial. 5 factorial take care of 5 factorial. I'm left with this time which is 336 ways. 336 ways. Okay. The next question. They said if the mathematics department of ASUT has 5 members, of staff, and they are to pose for a photograph by standing in a row. Full stop. How many different arrangements is possible? Okay. Now they are to stand in a row, and if they are standing in a row, they can stand in 5 different ways. I am sorry, they have five. In fact, they have 5 spaces to stand. Okay, because somebody standing, you cannot say that there are 3, unless maybe you created a box and say that they have to stand inside that box, and that box you created is maybe 2 or 3. So since they are just to stand in a row, okay, or maybe watch this one. They say, in how many ways can 8 people be seated in a bench? If they just say that they are to be seated in a bench without telling that that bench can contain 3, then it simply means 8 permutation 8, or just 8 factorial. Okay, so solution, since they are standing in a row and there is no restriction to it, so it simply means just 5 factorial. That's the answer. Okay, or you say 5 permutation 5, just say 5 permutation 5, and 5 permutation 5 means what? 5 factorial all over what? 5 minus 5 factorial, which is what? 5 factorial all over 0 factorial, and 0 factorial is 1, so I'm left with 5 factorial over 1, which is what? 5 factorial. So when somebody is sitting in a bench, okay, without any restriction, or standing on a row without any restriction, it simply means n factorial. That's all. Or n permutation n, anyone you like, the same thing. Okay. Okay. So the next question answered, in how many ways? Okay, let's talk about permutation of distinct n object. Permutation of distinct n objects, okay, of which n1 are of one kind, comma, n2 of second kind, dot up to k of what? K of k kind. Okay, now how do you do this? It's simply is simply n factorial all over the first one, n1 factorial, n2 factorial, dot 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 up to nk factorial. Okay, as simple as that. Let me show you what I mean by this. Let me show you what it's very simple. Let me show you what I mean. Forget about the English I just spoke. Let me show you what I mean. Example. They said in how many ways can 3 yellow, comma, 4 red, comma, and 5 blue balls be arranged, okay, be arranged in a string of x mass 3 light with 12 sockets. Okay, solution. Now you see we have 12 sockets to arrange 3 different things, and that 3 different things is what? 3 yellow, 4 red, and 5 blue. So the solution is simply very simple. The solution is simply that 12, the total 12 factorial all over. Oh yeah, let's go. 3 factorial, 4 factorial, and 5 factorial. As simple as that. And my answer becomes what? 12 times 11 times 10 times 9 times 8 times 5, no sorry, times 7 times 6 times 5 factorial all over 3 times 2 times 1 for this one, times 4 times 3 times 2 times 1 for this one, then times 5 factorial. So that 5 factorial can cancel 5 factorial. I'm having that 3 times 2 is 6. This is cancelling this. 4 times 2 is 8. It's cancelling this 8. 3 will cancel here to have 3. So I'm left with 12 times 11 times 10 times 3 times 7. So I'm left with 12 times 11 times 10 times 3 times 7. So my answer becomes so just find the solution, and then that is that. I can clean here. Let me give you another example so that you understand this one. Okay, another example said, in how many ways can the letters of the word mathematics be arranged? Okay, solution very, very simple. Just count it. Okay, they are 1 2 3 4 5 6 7 8 9 10 11. They are 11. Just say that 11 factorial all over. And I start counting. M is how many? 1 2 factorial. A is how many? 1 2 factorial again. T is how many? 1 2 factorial again. H is how many? 1. I'm supposed to write 1 factorial, but 1 factorial is 1, so no need. E is how many? 1 factorial. I'm supposed to write, but 1 factorial is 1. Is there another one I'm missing? So that is that. Is there anyone I'm missing? Mathematics. Okay. A is how many? Mathematics. Okay. So that is that. And that is that. So just get the final answer. You are done. Okay. So that is that. Now this is without restriction. We'll be giving you the ones with restriction as time goes on. Let's just be learning the little ones. Okay. So the next thing we're going to talk about is cyclic permutation. Okay. Now, whenever you want to arrange anything, in a circular form, Okay, the ways of arrangement of anything at all in a circular form, the ways of arrangement of an object in a circular form is simply n minus 1 factorial. That's just the answer. Okay, n minus 1 factorial. Okay, that is for A. Now for B, they said if the objects are fixed in a ring, which can be turned over, comma, the number of arrangements. Number of arrangements is simply that n minus 1 factorial divided by 2, half of this one. If the ring can turn, okay. So let's solve some question on that so that you get what we are saying. So note that if for an object to be arranged in a straight line, okay, or in a bench or in a row, just straight line, it means just n factorial. But if it's in circular form, it is what? N minus 1 factorial. As simple as that. Okay, so please note it. Note it. Very, very important. It's an exam question. Note it. So, example. They say, in how many ways can eight men be seated at a round table? Comma, they say if two particular there's a restriction here. If two particular men refuse to sit together, okay. Now don't forget that two men refuse to sit together, okay. Two men refuse to sit together. Now watch me now. Let me show you how to do it. Solution. Now let me represent these 8 men with alphabet. A, B, C, D, E, F, G, H, I, J, K, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now these are the 8 men. Okay, solution. Oh, these are the 8 men. Now without restriction. Now without restriction, that is nobody, as in there is no condition attached. My answer is simply n minus 1 factorial. Why? Because they are sitting in a round table. But if it's in a row, it will just be what? N factorial. So my answer is simply 8 minus 1 what? Factorial. Are you with me? So which is what? 7 factorial. And 7 factorial, they just get the answer to 7 factorial. 7 factorial means 7 times 8 times blah blah blah. 7 times 6 times 5 times 4, like that. Now let me say that the men that refuse to stay together is just maybe C and D. They refuse to stay together. Now you cannot get when they are not together, please. First of all, how to get when they are not together is, first of all, get without restriction. Now get when they are together. Use without restriction minus when they are together is now when they are not together. So if we say that C and D are now together, look at what we are going to have. We are going to have A, B, C, D together as one. Then E, F, G, and H. Okay, how many do we have here now? 1, 2, 3, 4, 5, 6, 7. Now we have 7. So these 7 men is what we are now arranging in what? In that round table. Okay, so if we arrange these 7 men in this round table, the arrangement of this, normally to arrange these people is in 2 factorial. I hope you know the 2 of them. To arrange them is in what? 2 factorial. To arrange them is in 2 factorial because this person can just sit here, the other one can sit here, okay, in 2 factorial. Then times arranging these 7 people now in a circle means what? That's 7 minus 1 factorial. But if it's in a row, it's going to be just 7 factorial. So I'm having what? 2 times 1 times what? 6 factorial, which is what? Just get the answer. So if I get the answer, I'm going to have 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. So what do we have? And the answer to this one is 7 times blah blah blah. So my final answer, so 7 times what am I saying? 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so I'm going to have well, can you get my calculator? So in fact, my answer is simply without restriction minus when they are together. Are you getting it? So the 2 men refusing to stay together. Thank you very much. So let's get the answer now. So I'm having 7 times 6 times 5 times 4 times 3 times 2. Okay, so this is 5,040 ways. Okay, why this one will give me, let's do this one, 6 times 5 times 4 times 3 times 2 times 2 again for this one. So I'm having 1,444 zero. Okay, so therefore the men refusing to stay together, the men refuse, the men not sitting together, the men not sitting together is simply without restriction, which is 5040 minus when they are now together 1440. So what do you have? So I'm having 3600, okay, as the answer. So that is that. Now let's take another question. Let me check my time. Okay, let's take another question. The next question we're going to look at is a family of 7 is to be seated round a table, full stop. In how many ways can this be done? In how many ways can this be done, comma, if the father and mother are to sit together? This is city, sorry. Okay, are to sit together. That's solution. Now represent it with alphabet. I have the 7 family: A, B, C, D, E, F, G. Okay, these are the 7 families. Now without restriction. Okay, in fact, we don't even need without restriction. We just need that let the father and mother be this one. This is the father and mother sitting together. So I'm going to have the ways of arranging the father and mother is just what? 2 factorial times. But the ways of arranging, how many are there now? 1, 2, 3. They are now 4, 5, 6. Okay, so it's going to be what? 6 minus 1 factorial. As simple as that. So which is what? 2 times 1 times 5 times 4 times 3 times 2 times 1. Okay, so my answer becomes 240 ways. Okay, so the next one. Okay, the next one said, in how many ways can 8 boys be arranged be arranged around a circular table. Okay, it's simply 8 minus 1 factorial, which is what? 7 factorial. That's all, nothing again. And 7 factorial is 5040. That is 7 times 6 times 5 times blah blah blah. So that is that. So the next one we'll now look at in our next video is now permutation of digits. Permutation. Okay, thank you very much for watching. Please subscribe and share to anyone that needs the video. May the peace of the Lord be with you.